National 5 Maths, Practice Paper H, Paper 1. Now in question 9, what we have to do is to find where the two lines intersect. Now it specifically says we have to do it algebraically. And that just basically means that we're not allowed to draw a graph and just find out from the coordinates, just plotting the lines and looking at the coordinates where they intersect. So we've got to do it algebraically. So we're going to use simultaneous equations. Now normally when you use simultaneous equations, you've got your x and your y on the same side of the equation, like this one here. We've got x plus 2y equals 14. But the first equation isn't like that. So what I'm going to do is I'm going to subtract 2x from both sides. So that equation is going to be y minus 2x equals negative 3. Now this one goes x and then y, whereas that's the other way around. So I'm just going to swap it around, but watch, it's negative 2x you need to have first, plus y equals negative 3. So we've got this equation and we've got this equation here. So we're going to do that simultaneously, find out the value for x and y, and we've got to write it down as a coordinate because it specifically says you've got to find a coordinate here. So writing that down, we can solve that algebraically. Now you can use substitution as well to solve it, but majority of you will probably be happier doing it using elimination. So we can eliminate either the x terms or the y terms. I'm going to eliminate the x terms, so I'm going to multiply this first equation by 2. So the second one's not going to change at all, so the first equation is going to become 2x plus 4y equals 28. Second one stays as it is. And we've got that. Now we can see we've got 2x and we've got negative 2x there. So if we add those together, those are going to cancel out. So we end up 4y and y is 5y. 28 plus negative 3 is 25. And dividing by 5, 25 over 5 is just 5. So you can go back to any of the equations that you've used. Just go back to one of the original ones. The first one in the question was y equals 2x minus 3. So we can just use that. So y is 5. So we're going to sub that in there. So 5 equals 2x minus 3. Add 3 to both sides. Divide by 2. And we get x equals 4. So you get 4, 5. We can then perform our check. Now that's not going to get you any marks, but just to see if you've done it correctly or not. So we go back to the other equation that we had in the first place. X plus 2y equals 14. Just check that's going to work for us. So we're not going to say x plus 2y equals 14. We're just going to say x plus 2y. We're going to sub in our answers of x is 4, y is 5 into this. See if it gives us 14. And if it does, brilliant. And if not, we'll have to go back and see where we've gone wrong. So if x is 4, plus 2 times y, 2 times 5, so that's going to be 4 plus 10, 14, happy with that, so I know that my answer has to be correct. Now in question 10, this is quite a quick question, it's just asking us to state the values of a and b, and it tells us we've got a cosine graph, y equals a cos bx, in the diagram here. Now we can see the maximum is 5, minimum is negative 5, so that's going to be your value is going to be 5 for a. So we've got to specifically state a equals 5. Now the period of the graph is 90. Now you might think it's repeating twice within 360, but if you look at the scale carefully, that's actually only goes up to 180 there. So if it repeats within 90, it's going to repeat 4 times within 360 degrees, which means that that value there has to be 4. So b is equal to 4. And in question 11, now this is a non-calculator paper, remember, and you can see it's got costs of something, which might make you think, oh, I need a calculator for that, but you don't. It tells you to show that cos of b is equal to 5 over 9. So we've got a triangle, we've got 3 sides, that's an indication we're going to be using the cosine rule. Now if you look at your formula sheet, it gives you 2 forms of the cosine rule. The one for finding an angle, because we've got all 3 sides, so we're not going to find any sides here. So we're trying to find angle B, so it's cos B. Well, let's write down what it tells you in the formula sheet and we'll just change the letters around. It tells you cos A equals B squared plus C squared minus A squared over 2BC. But it's not angle A that we're looking for here, it's angle B. So I'm just going to change the A's for B's and vice versa, B's for A's. So my formula is going to be cos B. So I've changed that A for a B, I'm going to change that A for a B there. So b squared plus c squared, so it's going to be a squared plus c squared over 2ac. Now we're not actually finding the angle, we're just finding out what cos b is equal to. So cos b, we've got cos b there. So essentially all I need to do here is sub in the values for a, b and c into that and tidy it all up, and it should give me 5/9 if I've done everything correctly. Now going back to the triangle, if that's angle A, that's side A. Angle B, so side B. Angle C, side C. So it'll be a squared, so that's going to be 6 squared plus 3 squared minus 5 squared over 2 times 6 times, what was it, C, 3. So if we tidy all that up, so it's 36 plus 9 minus 25 over 2 6 or 12 times 3 is 36. Now, you might think you can cancel those, but you can't. It's not a common factor. We've got to add all that together, and then you've got to see if there's any common factors after that. So 36 add 9 is going to be 45. 45 take away 25 is 20. So we're going to get 20 over 36. Now 20 and 36 are both in the 4 times table. So dividing them both by 4, and we get 5/9. And that is what we were asked to show. Cos b equals 5/9.